Okay, so today we will be um learn about we will learn about foundation of supervised learning. Now, in this, we will first see what supervised learning is, then the relationship between input versus output, then types of data in supervised learning, and then task types in supervised learning. And then we will discuss about different. Okay, I'll come to that later. So I will add this. I will add this, update this mind map as we move forward. So first of all, let's discuss what is supervised learning. So supervised learning is basically a type of ML, right? It's a type of machine learning where the model is trained using labeled data. Okay, what does labeled data means? Labels means the output. So we will be giving with features, and features are known as input variables. And we will also be given with labels. So labels are actual output, right? Or ground truth. So the model will learn the mapping of X and Y. So it will learn the mapping of features with the labels, and then basically the prediction is being made. So there are a lot of things that we basically do when we do supervised learning, when we basically handle the regression and classification cases. So I'll come to that. But yeah, this is the definition of supervised learning. Now, supervised learning, if I'm talking about supervised learning, and if I'm talking about the relationship between input and output, so what it basically means, so I have, let's say, output defined as y. So y equal to a function f, mathematical function, right? You might have studied that in your elementary school, right? Y equal to fx. So f represents function. So function of x1, comma x2, comma x3 till xn. So this represents the equation, general equation. Okay, now x1, x2, x3 till xn are the features basically. So यहाँ पे in this example, x1, x2, x3 till xn, whatever is there, these are actually the features or the input. Y is known as actual output, and E is known as error term. Now, what happens for predicted output? We basically define it using y cap, y, and then we have a cap symbol over it like this, right? Y cap, and y cap is equal to f, and then x1 comma x2 till xn basically. So y equal to y cap plus E. So that's where the calculation of error terms comes into the picture. That means the predicted output will be there, but with some error. And to find that error, and then to find whether our model is predicting correctly, whether it's an overfit model, whether it's an underfit model, is actually the meaty stuff that we do in machine learning, right? So we will learn that gradually how to do that. But yeah, this is how the input and output as well as the predicted output relates to each other. Now, talking about type of data used in supervised learning. So first type of data is basically uh, structured data. So structured data may basically the structured data if I'm talking, so it is CSV, comma Excel data. Then we have text data. So text data may you will be having sentences. So sentences, reviews, documents. So whatever you might have seen in natural language processing, right? So these are the types of data there, text data. Then we also have image data. So image data basically contains like pictures, photos of cat and dog we are providing, and then we are asking it to classify it, whether it's a dog or a cat, something like that. Then we also have audio data. So audio data basically contains sounds or speech, right? When we are doing the word transcription, then audio data comes into picture. Next is video data. So video data is kind of sequence of images, right? Sequence of images. That's how we treat video data. Then we have time series data. So time series data means data over time, over a period of time, right? So past prices, let's say there are stock data is there, right? So stock data contains stock prices in the past in a time series manner. And then we use that data to do some prediction for the future or, to do some prediction over a product. So that is time series data. And then we have a hybrid data or a mixed data. So mixed data is basically any mix of the above data that is being mentioned in this mind map. Okay. So this is about types of data used in supervised learning. Now, important thing, task type in supervised learning. So there are two type of tasks, regression and classification. So when we are talking about regression, it is about predicting continuous value or a number. Predicting continuous value or number. So whenever, let's say, in any use case, whatever we want to predict is a value or is a number, then that's the use case of regression. For example, we have given the example that we have seen yesterday, right? Square feet, size of the house, bedroom, location, and finally we are predicting price there, right? So price is a number that we are predicting. So it's an example of regression task type in supervised machine learning. And if I'm talking about classification task, so it basically predicts categories or class. So category or class means the output will fall in any of the allowed class. For example, let's say we have given some data to our model and then it is predicting yes or no. Yes or no, let's say if you want to predict whether a mail is a spam mail or not a spam mail. So there are only two predictions. There are only two classes, spam and non-spam. And output of all the data or output prediction basically will fall under one of these categories. Either it will be a spam email, either it's a non-spam email. And output is not a continuous value or a number. So this is the case of classification. So we'll discuss more on regression and classification once we will pick these, topics separately. But yeah, this is what the definition of regression and classification looks like. Now, if we'll talk about regression categories, if I'll tell, so categories on high level, they belong to either linear or non-linear. Similarly, the categories for classification, it's also linear and non-linear. Non-linear category, if we'll see linear category for regression, it means that it predicts using a straight line. What it means is that if we will draw the graph between x and y, x means feature and y means label, then x will have some values, right? So it is input values, and y means the output values, right? So mostly in linear regression, the prediction y will basically uh, lie on the straight line. For example, if x value is 2, the price will come as, let's say, 20. If x value is, let's say, 8, the price will come somewhat like 80, something like that. So this prediction using a straight line is linear, and it's not a perfect straight line. So most of the data is predicted using a straight line, hence it is basically known as linear. Non-linear prediction, non-linear regression type, what happens? So it can be any mathematical graph other than a straight line. So it can be any, like this. So relationship between x and y will be non-linear, something like this. So it is known as non-linear. Now, when we are talking about classification, so classification, let's say if I'll draw the graph of classification, and there will be two categories. So let's say categories to spam and non-spam is there. So this is, let's say, spam. And another category is non-spam, like let's say non-spam. So these are some of the data points on the graph. And this graph can be separated by a straight line, right? So if you draw the straight line, you will be able to separate out the classes. For example, this is a spam, right? A spam email. And these are the non-spam email. So you are able to separate out the data using a straight boundary. Hence, hence this category falls under linear category of classification. Now, if we talk about non-linear category, let's say we have a graph and we have some, let's say, random data, something like this, and then probably like this, like this. So in this case, can you separate out the data with a straight line? If you'll draw a straight line here somewhere, it will not separate out red and blue dots, right? So in that case, what happens? You basically separate out the data with a non-linear, um, uh, basically non-linear curve, or multiple decision zones will be there. So you can see this separation uh, plane, or the separation line, is not linear. And when we draw this, so we are able to separate red dots with the blue dots, right? Like this, right? So this is the example of non-linear category of classification. So these are the two task type in regression and classification. Now we have algos. So regression algos and classification algos. I'll just give the overview of what linear regression and classification algos are. So if we'll talk about, let's say, I'm talking about regression. So regression will have linear and non-linear algorithm. So linear algorithm examples are, uh, basically linear regression, lasso regression, ridge regression, and elastic net regression. And if we'll talk about the example of nonlinear algorithms, so nonlinear basically contains support vector regression, then decision tree regressor, and random forest regressor, etc. Now, polynomial regression is basically, it looks like polynomial looks like nonlinear, but it basically so it basically, when we are defining the relationship, so linearity is there, non-linearity is there in X, but it is linear with respect to parameters. So hence it falls under the linear algorithm. So it's a very confusing concept in machine learning. But just FYI, so polynomial regression is non-linear in X, but linearity is there in parameters, hence it falls under the category of linear algorithm. Okay, so this is about regression. Now let me explain about classification. So classification under linear category, we have logistic regression. So term regression is there, but it falls under classification. So this is also tricky part, okay? Then we have perceptron model, naive Bayes. These are some of the linear, category under classification. If I'll talk about nonlinear algorithms, so under nonlinear, we have KNN, means K nearest neighbor, then decision tree classifier, random tree classifier, and then we have neural networks. Neural networks are also falling under nonlinear category. Neural network means CNN, RNN, all those. Now, if you look closely, you can see this decision tree regressor, random forest regressor, decision. Here also we have decision tree random. It is random forest, not random tree. Sorry, this is random forest. So decision tree and random forest are common, right? So there are some algorithms which are common, across. I mean, it basically counts uh, under both category, regression and classification. So let me note those also. So regression, if I'll talk about regression only algorithms, and then right hand side, let me write down classification only algo. Okay, so under this category, regression only algo, let's see what all algorithms we have. Okay, so regression only algorithms, when I'm talking, so linear regression, ridge regression, lasso regression, elastic net, quantile regression. So these are some regression only algorithm. Now, if I'll talk about classification only algorithm, so we have logistic regression, and then naive Bayes, and then we have linear discriminant analysis, quadratic discriminant analysis, softmax classifier. There are a lot many, right? You don't have to, worry about learning each and every algorithm, because data scientists used to study these algorithms in past when ML system and generative AI was not, I mean, generative AI was not, invented. But as the generative AI is progressing in today's world, so you just have to know about these algorithms. You can, study one or two algorithms just for your understanding, but you don't have to go deep down into these algorithms. Okay, coming back to the point, right? Now there are some algorithms which are both regression as well as classification. So they fall under both categories. So what are those? First is decision tree, Then we have random forest. Then we have KNN, K nearest neighbor. SVM, support vector machine, neural networks, gradient boosting, light GBM, XGBoost, cat boost. So these are some of the algorithm which basically contains both the capabilities to predict the regression task also, as well as to predict the classification task. So just remember that. And there are some algorithm like k-means clustering. They don't fall under any category. They don't do not K-mean clustering is a separate. It's neither a regression nor a classification. It has a separate task type, which is known as clustering task type, which we will study in unsupervised learning. So K-mean clustering is not for supervised. It is meant for unsupervised machine learning. Okay. So yeah, so this is the whole overview about regression algorithms, classification algorithm, and what are regression only algorithms, what are classification only algorithms, and what are algorithm which falls under both category, regression as well as classification. Cool. Now let's start uh, discussion on regression and classification one by one. So we will pick regression now. So regression, we will study what is regression. Then we will cover the linear algorithm, linear regression algorithm, the most commonly used mathematical equation behind that, and how do we interpret that. We will see those things. And then we will see the use cases. And we will pick the use cases and do Python coding. We will go step by step, nothing to, hurry in that. We will take baby steps so that we will learn properly. Okay. Okay, so let me create one more mind map just specifically for regression. So this is regression task type. Okay, so what is regression? So regression is a task which is to predict a numeric output from given input, right? So this prediction happen using different algorithms. So algorithm means procedures or methods where machine learns relationship between input and output, and those are known as regression algorithms, regression algos. And we have seen that it is divided into two parts, right? Linear algo and non-linear algos, right? And we have already seen what all algos lies in linear and non-linear, so I'll not repeat that. But yeah, uh, so when there is a linearity in coefficient, not necessarily the linearity between x and y. So I was showing you the graph between x and y, linear graph, right? But when we are deciding between linear algorithm and non-linear algorithm within regression, so it is more important to find the linearity between linearity in coefficients basically. So when there is a linearity in coefficient, it falls under linear category. If there is a non-linearity in coefficients, then basically it falls under non-linear. Now let's see the equation. So let's pick one linear algorithm. Which one to pick? Let's pick the most common, most famous linear regression. Okay, what is linear regression? Okay. So let me open. Okay, 1 second. It's not loading. I want to show it on Notepad. Let me close it and reopen it again. Okay, cool. So linear regression is what we will study. So linear regression, first of all, is basically, uh, okay, first of all, we will write down some points, important point. So in linear regression, mathematical equation that is used is linear equation. Okay, what is linear equation? I'll come to it later. And when we talk about linear regression model, so linear regression model, if we will build, so model means final formula, final mathematical formula that is built for prediction. So when we talk about any model, whenever model comes into the picture, whenever you hear model, just remember that model is a final formula, mathematical formula that's been built after the training, basically training on the data set. Then linear. Okay, so these are two important things I want to mention initially before proceeding forward. Okay, now let's talk about linear equation. So what is linear equation? Okay, so linear equation basically it is something like this: y equal to I plus c1 x1 plus c2 x2 plus still cn xn, and then we have error term e. Okay, yeah. So here important points to note is that y is known as actual output, and x1, x2 till xn, these are known as features, and I is basically something which is known as intercept. We call it as intercept, and e is known as error term. Okay. So this is the linear equation. This particular equation is known as linear equation. Okay.
What is intercept means?
So intercept is something when all the values for feature become zero, so your output should not be zero. It is the bare minimum thing, bare minimum, output when all the features or when all the component. I would say when all the coefficients become zero, then it should contain something, right? So that something is known as intercept. So
And
it,
why we are adding error term?
yeah, so error term, why we are adding? Yeah, I'm coming to that. So when we are predicting the value, why predict, right? So for y predict, the equation becomes this: I plus C1 plus C1 x1 plus C2 x2 till Cn xn. So here error term is not included because what we consider is that uh, that error term, it basically contains the error term. Predicted output contains some error component. And when we basically minus y, matlab actual output minus predicted output, when we will do from these two equations, we will get error. So that is the whole concept. Means prediction will be happening, some prediction will be there, and actual output will be there. Actual output is defined by this equation. Predicted output is defined by this equation. When I will subtract these two, then what I will get? I will get E, which is error term, which basically signifies that there must be some error in your prediction, and then based on that error we will do further calculation. So this is how it is represented. Okay, now if you look closely, so let's focus on this particular equation. Let's focus on this particular equation, this linear equation: I plus c1 plus c1 x1 plus c2 x2 plus till c1 cn xn. Now, there are two perspectives. Okay, let me write down these two perspectives. First is classical classical math perspective. Second is ML perspective. Okay. Okay. So what is classical maths perspective? We'll see. You might have seen the linear equation in your school days, right? For example, 3x1 plus 2x2 equal to, let's say, 16. And then second equation is given as x1 plus 3x2 equal to 17, something like this, right? And you were asked to find the value of x1 and x2, correct? This is a very common thing that everyone from any stream, right? Commerce or medical stream or engineering stream, anyone who had gone through elementary school, 10th class, they have encountered these kind of linear equation, right? 3x1 plus 2x2 equal to 16, x1 plus 3x2 equal to 17. This, I'm just giving an example. So, and you were asked to find the value of x and y, right? Sorry, x1 and x2. So in this case, unknowns, what are unknowns? Let's write it down. What are unknowns here? Unknowns are x1 and x2. What are known? So known are y and coefficients, right? So from where I'm correlating this? I'm correlating from this linear equation, universal linear equation, right? So यहाँ पे you can see 16 and 17 is there, which is y, kind of a y, right? And coefficients are known, which is 3. Here it is 3, here it is 2, here it is 1, here it is 3. So unknown is x1 and x2. Known things are y and coefficients. And number of equation needed to find unknowns. So number of equation needed to find unknowns are equal to total unknowns, right? Agree? Everyone agrees with me? So if x1 and x2 are two unknowns, so we need two equations to find these two unknowns. If we have x3, x1, x2, x3, then in that case, to find x1, x2, and x3, all three, x1, x2, x3, we will be requiring three equations in that case, correct? Right? So number of equation required is equal to total unknowns. Okay, sorry, this is total unknowns. I should have written total unknowns. Okay. And what is the goal? Okay, solution. Let's talk about the solution. So the solution, final solution that we will get will be the exact solution. Exact solution means you will get the exact value of x1 and x2 when you will find when you will use these two equation and find the value. So the solution is exact here. And ultimately, our goal was, or our goal is here in this case, is given coefficients, solve for unknowns exactly, or exact value of unknowns we have to find. So this is classical math perspective. Now let's come to machine learning perspective. Now machine learning perspective, let's say we have a data set. That data set contains, let's say, 100 of rows. Okay. So our equation will form something like 1200 C1 plus 20 C2 equal to 50. And this will go on till total rows, right? Let's say if we have 100 rows or 1000 rows, it will go on till there, right? Now here, what are the unknowns? Here unknowns are coefficients, right? If you just listen carefully, very carefully, right? We are just referring to this equation only, linear equation, but there are two perspectives. Maths perspective we have seen, now we are seeing the machine learning perspective. So here in machine learning, unknowns are coefficients. So you take an example, right? We have taken the example 1200 square feet ka house plus, let's say it has 20 bedrooms. So 1200 you will write it down as x1. So this is x1 basically, but you know the value of x1. So it is C1 and C2 which is unknown. So known, what are the known things here? Known things are x1, x2 till xn. That means features or inputs, right? So inputs and features are known to us. And what else is known? So y is also known, right? Output. You can see, yeah, this is y in that case, right? When you will refer the linear equation. So y is known, x1, x2 is known. So features or inputs are known and output is known. Here unknown is coefficient, and in classical math perspective, unknown was features x1 and x2. Okay. Now next point.
Um,
Yeah,
I
go
mean,
ahead.
like C1 and C2, they are not part of feature input because that also.
I'll come to that. I'll come to that. That's where the confusion comes now. So you can think कि 1200 C1 की जगह let's consider 1200 as coefficient and C1 को let's consider as input, right? But that's not the exact thing that we are doing here. Now, next thing, let's see what is next thing that we can deduce from here. Here, number of equations, how many number of equations will come out? Number of linear equations. It will be equal to total samples in the data set, right? Correct? If data set has 100 rows or 1000 rows, and eventually for those 100 or 1000 rows, when I will come up with the final, equation for each row, so total how many equations will be there? It will be equal to total samples in data set, right? And our goal is to find the best possible value of C1, C2 that represent that 1000 or whatever data is there in the data set. That best describe the relationship between X and Y. So solution in this case, when we will find, it will be the approximate solution, right? Maths में we will be finding the exact solution, and यहाँ पे solution is approximately, and goal is, let's write down the goal also, classical ML goal, given input and output, solve for coefficients that best explains the data. Okay. You can see here in classical maths, we have a different goal. And here in ML perspective, we have a different goal. Now, it feels like swapping the coefficient and input makes these equation interchangeably, right? So you can think, okay, both of these are, linear regression equations. यहाँ पे we are mentioning it as x1, यहाँ पे we are mentioning it as c1. So instead of c1, let's mention it as x1, and then we can consider this 1200 as c1, right? No, that's not the goal, because when we do that, our definition of unknown will basically change, and so do our goal. So just remember what are the unknowns when we are discussing about the classical math perspective. What are the unknowns when we are discussing the machine learning perspective? And we cannot interchange these values, even though it will look like that, okay, we can interchange the value. I mean, we can interchange the thinking, and we can think C1 as X1, C2 as X2, but no, just remember that unknowns are different in both of these two perspectives. So as soon as we are changing the definition of unknown, it will by default change our goal. So in machine learning, X1, X2, X3 or features are always given to you, output is given to you, and your goal is to find or solve for the coefficient that best explains the data, and the solution is approximate here. So C1 ka value which will come out of machine learning training, it will not be exact value, but it will be somewhat kind of a, the best value that can come out from this data, which will explain your data relationship between the data. Okay. And in classical math perspective, the output or the solution that you are getting is exact. So x1 and x2 ka value, whatever will be coming out, will be the exact value. It is no if and but will be there. It will be the exact value which you will get in this. But here in ML perspective, the coefficient value is basically the best possible coefficient value you will get. And if let's say coefficient, you got some coefficient value, you have evaluated your model, and then you find out, okay, your model is not good. Then again, you will, do the retraining and find coefficient values, and probably this time the coefficient value will change to what it came before. So those coefficient values that you will find during ML training are approximate value, which best explains your data. Okay, any doubt?
Yeah. So here, ML perspective, we are saying it's a approx calculation, approx solution or
Right.
the data. And here we are not okay. So I mean, what is the logic? Like here we are saying approx, and the other one classical maths we are saying as exact.
Because see, classical maths, we are saying it is approximate because यहाँ पे you have to find the inputs, right? X1 and X2 are the inputs, and total number of inputs. Uh, if you have two equation and two unknowns, you will be able to find x1 and x2. यहाँ पे when you will do 3x1 plus 2x2, यहाँ पे multiply करोगे, let's say with this equation, when you will multiply by 3, then it will become 3x1 plus 9x2 equal to 17 into 3, and then plus
No,
minus
that I
करते हैं,
got
right?
it. We will
So
get
you
the
will get,
next.
exact value, correct?
Yes.
Now think that your data set has 1 million of lines, right? So 1 million of line, matlab there are 1 million of equations that your system has to go through. When
Mhm.
your system will go through 1 million of equation, it will do some calculation, and it will come up with a mathematical formula that will best explain your data. So in that case, it will not exactly explain your data. Why it will not exactly explain your data? Because uh, for some value of C1 and C2, you will get the perfect value of 50. But for some values of C1 and C2, you may not get the value 50. You may get, let's say, 49 or 48 or 52. Okay, so this will be clarified once we'll take the Python example for linear regression use case. But I want you to look into these two perspectives, because this is the common confusion that people get, that 3x1 2x2, so this is something that we used to do in our mathematical days, right? But here we are calling it as C1 and not x1. Why we are not calling it as x1 here, and we are calling it as C1? So this is the difference. The definition of unknown changes.
Okay.
Okay. ठीक है, so don't get confused too much in this. Once we will take the example, na, you will come to know. Okay.
Also, like we are saying I plus C1 X1 and
Yeah.
E. So if we get example with that also, that will.
Mm-hmm. Yeah. So intercept. Yeah. So that is where. So we will basically, what we will do. We'll take an example. We'll build a Python code. We'll form a final equation like this, something like this, and then we will see what is the significance of I, and what is the significance of C1, C2 in that particular the final equation that model comes up with. So we'll do the data analysis at last. Okay. Cool. So this is about linear regression. Now linear regression. Okay. So linear regression is basically divided into two categories. So first one is simple linear regression, and next one is multiple linear regression. Okay. What is simple linear regression? So simple linear regression means we have just x1. We have only one input, one feature only. And multiple linear regression, we have more than one features, one input, right? So simple linear regression may, when we have only one feature, your equation will something look like y equal to I plus just C1 x1. Okay, because we have just one input here. And this particular example that we have taken so far, this is the example of multiple linear regression, where you can have more than one features. So this is about linear regression. Now let's see some of the use cases that uh, that can be there for simple and linear regression. Okay, first use case. Let's say, okay, so we have to predict sales based on advertising spend. Okay, what does it means? It means that let's take some real world stories. Let's say a startup spends rupees X on ads, want to estimate expected sales. So the marketing team wants to know that if we increase ads by 1 unit, how much sale will increase. So so increase in the ads by 1 unit and how much sale will be increased. So this is a classical case of simple linear regression where we have only one feature and only one feature. So यहाँ पे data set में if you look, the feature will be advertising amount and label will be X. So if you can see, we have only one feature here, right? We have one feature here, and that is advertising amount. So this is the case of simple linear regression. Now the data that these team will get, they will get from their CRM or billing systems or from advertising platform. Okay. Similarly, we can have more use cases. So predict house price from area. So here, let's say we just want to predict the price of the house from the area, square feet area. So as we are taking just one feature, which is the area, square feet. So this is the case of simple linear regression. So in simple linear regression, you will basically take just one feature. Now, real world, source of data set for this will be again real estate listing and builder CRM. So there are many ways in which we can get the data, right? This data which we can feed to our machine and then do the further analysis, right? So, so these are some of the use cases for simple linear regression. Now let's see some of the use cases of multiple linear regression. So we will take the example of advertisement only, but here we are dividing our advertisement into three categories. So TV, radio, newspaper. So there are three kind of advertisement that company is spending on. So यहाँ पे data set, if we'll talk about the data set, यहाँ पे feature will be three features will be there, right? If you can see here, we will have three features: TV advertisement, radio advertisement, and newspaper advertisement. So amount spent on these three advertisement. So as we have more than one feature, it is the case of multiple linear regression. And when we will, design the Python code, basic Python code for this, we will take this advertisement wala example. We'll take, first of all, we will, see the example of advertisement in simple linear regression case and then in multiple linear regression case. We'll take this same example. Then we can have more examples also, right? Predicting the house price and uh, predicting house price using multiple factors. Initially, we have seen in the case of simple linear regression, we have just considered area. Now, in this case, we will consider not just area, we'll consider number of rooms also, house age also, location, something like that. Okay. So these are some of the use cases. And what I will do, whatever example I'll take, uh, I'll be probably sharing. I'll share these examples with you, and as a homework, you can take other examples and try to build Python code over it. Okay, enough of theory. Now, next thing, we will be basically we will basically do the Python coding for simple linear regression first. Just to start with a simple thing. So simple linear regression, we will see how we will build a Python code using it. And before that, let me tell you what exactly will be our strategy. First of all, we will see basic flow of simple linear regression using Python. So basic flow means we will just see how to use the ML libraries, Python ML libraries. We will not calculate the error. We will not calculate for performance of the model. We will just use a very simple. We will just take a very simple example and we will see how do we use the Python libraries. That is our first intention. Then next step we will see how to use or how to build a basic flow for multiple linear regression using Python. Okay. After that, we will learn the statistics of regression. So statistics may R square, sum of squared errors. There are many terms and many things in that. We will study all those first. Then we will see how do we calculate for overfitting and underfitting, or basically whether we will see whether a model is a good fit or not. If it is not a good fit, then it will fall under a category of either overfitting or underfitting. That we will see. So once we learn statistics and once we will learn the concept of overfitting and underfitting, then we will build complete ML pipeline for let's say multiple linear regression. So in this complete ML pipeline that we will build, so here we will first of all train the model, and then we will calculate the parameters that are required to calculate whether the model is a good fit or not. Then we will find whether model is a good fit. If it's not a good fit, whether it's a overfit or underfit. So we'll build all that logic in Python. Okay, so I just want to share this step by step, uh, uh, basically the strategy that I'm going to take while teaching you the regression use cases using Python. Okay, so let's take an example. Okay, let's take 5 minutes break today, and we'll meet up after 5 minutes and six. Okay, this is 6:55. So 7:30, I have to drop off actually. So let me start a timer for uh, 5 minute. Okay, I'll stop. So it is a 10-minute timer, but yeah, once it will reach to 5 minutes, I will just resume the session. Hey everyone. Okay, so what we are going to see now, we will build a basic, simple linear regression flow using Python. Okay. Now let's build a code map for it. So code map is basically something which means the steps that you are going to implement in your code. Okay, so basically, first step will be to do uh, necessary imports. Okay. Second step will be to define sample data set. So we will define sample data set using Panda library. And then next step will be define features and labels. Then we will do train test split. We are doing train test split only because these are very basic example. Validation wala part I'm not taking here. Validation split we will do when we will learn about deep learning models. So for all ML models, I'll be just doing the train test split. Okay. Split. Next step will be define model. Next step will be make prediction. Then next step will be prediction on new data set. And then display final mathematical equation. Okay. So this is the code map. So let's open PyCharm. Now, in order to basically install the machine learning library, so scikit, SCIKIT underscore scikit learn is there. Okay. So if I'll do pip install scikit learn, I have already installed it. Requirement already satisfied. But yeah, once when you are um, using it first time, so this is the library that you will basically import in your machines. Scikit learn. So let's basically create one more Python module, Python file, and name it as simple linear regression. Okay. Let's copy the code map. What is the code map? So this is the code map. Paste it here. And we will put comments. So this will serve as a steps. These will serve as a steps that we have to implement in our code. Okay. So to do necessary import, so this we will, as and when some import is required, it will be added under this section. Now defining sample data set. So what is the sample data set that I'll be defining? I'll tell you. So we will be having the data under two rows. First one will be advertising. Second row will be sales. So we will take some values under advertising and sales. For example, let's say we have a value 6 and sales may 6.1 is there. So it represents that when you are spending $6 or 6 rupees on your advertisement, then out of that you are getting 6.1 rupees sale. So this is the data that in real world you will collect this data from your systems and then you will pass it on to your machine learning models, right? But here in our example, we will just form this dummy data so that we'll see how the things work under the hood. So let's create this dummy data. So we'll create this data. For that, we will create one variable data equal to, and under this, so this is a dictionary, right? So dictionary is what? Key value pair. So the first key I will use will be advertising and value will be the list of values that I want to take. So let's take from 1 to 10. 1, 2, 3, sorry, 3, 4. Okay, till 10, let's keep it. Okay. Second key will be sales key. And sales may let's take values as some random values 1.5, 2.1, 2.9, random 4.2, 4.8, 6.1, 6 point something else, 9, let's say, 8.0, 8.8, and 9.9. Do we have 10 values? 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 10 values. So this is a dummy data that I have defined. Okay. Now this is a dummy data and data I have defined in terms of a Python dictionary. I have to convert this to pandas data frame first. How do we create data frame? So we'll basically, you can use any variable name, but we use the word, we use the variable name as df, which represent data frame. And what we will do, pd.dataframe, and inside this data frame, we will be passing dictionary and we have to import pandas. So first import is added here, import pandas as pd. यहाँ पे we will be passing pd.dataframe. Inside that, we are passing this data. This is a dictionary that we are passing, which will basically ultimately create a data frame. So I have created data frame. Okay, so this step is implemented. Next step. Now we have to define features and labels, right? Can anyone tell me which out of these two will be feature and which will be label? Anyone? Sunny, if you can let me know. It's a very simple, right?
Yeah.
So feature will be,
Sales will be label and
yes.
advertisement will be.
Yeah, so let's define that. So we will define X. X means labels, features, features. And how we will define? We will define as DF like this. Advertising. And Y I will define as DF and sales. Now you can see here, there are a couple of things which we can learn from here. First of all, X is denoted in capital letter, Y is denoted in smaller letter or lowercase, right? X में we have created a data frame, we have given a 2D array, यहाँ पे independent variable, right? Even if we have just one variable here, one feature here, then also we have defined it as 2D array. And यहाँ पे it is a single 1D array, right? Now, why this is happening is because when we basically represent the linear equation in terms of matrices, so in terms of matrix or matrix, we define it as y equal to x w. X w, w means here w is a coefficient, right? So this is a feature matrix. This is a label matrix. So label matrix is defined as a 1D array because label, if you'll see, right, in any data, you will have features here and output will be just one value, right? Even if you have more than one feature or even if you have just one feature, in both of these cases, output will be one, right? So Y, that means output is defined as a 1D, one-dimensional vector or one-dimensional matrix, and X is defined as two-dimensional matrix. And in naming convention of matrices, second two-dimension matrix is represented by uppercase letter, one-dimensional matrix is represented by a lowercase letter, and that is where we follow this rule basically, where we define feature with capital X and label with small y. Okay. So we have defined our features and labels. Now we will do train test split. So left hand side, we will do multivariable assignment, right? So we will do X underscore train, X underscore test, Y underscore train, Y underscore test, and we will use train test split train test split function, train test split function of sklearn model dot selection. So यहाँ पे as soon as I have used this, you can see it has imported it, right? sklearn dot model selection में से it has imported this particular function. Now here, what I want to split, I want to split x comma y, and test size is 0.2. This means he out of all the samples, keep 20% as test data for testing and rest 80% for training. So 80% and this will be 20%. So 80% जो भी data होगा, this will be a training data and 20% will be the test data. So that's what test size denote, 0.2. So we will get x train, x test, y train, y test. That means, okay, so that means whatever advertisement and sales ka I have 1, 1.5, 2, 2.1, something like this is there for my data, right? So out of that, it will be divided into two parts. First part, second part. So ये वाले features जो हैं, this will be denoted with X train. These will be denoted with X test. Okay. Similarly, labels under training data, this will be denoted with Y train, and lower part, this one will be denoted with Y test. Okay, so that's what it means here when we are doing train test split. X train, X test, Y train, Y test, and train test split will automatically split all these data, and it will eventually automatically fall under these variables. And what are these variables? I have explained you. So this is the train data, this is the test data. So features under train data will be X train, features under test data is X test. Similarly, labels under train data is Y train, and label under test data is X test. Okay, so this is the train test split that we have done. Now let's define a model. So when we are building the actual machine learning pipelines, so there we use couple of models all together, and then but the logic becomes very complex. So what we do, we define more than one type of models, and later on we will build a logic so that out of all the models that we have defined, it will basically pick up our logic, our coding logic will basically pick up the best model out of the models that we have defined. But for understanding purpose, let's define a very simple linear model, right? So I will define a variable model equal to linear regression. So linear sklearn model. Okay, so this is what I have to import, linear regression class. So this is the model that I have defined. So I have defined a linear regression model. We have seen many models, right? Linear regression, lasso, elastic net, decision tree regression. Remember, right? We have discussed in the starting of the class. So we have taken a very simple linear regression model and we have defined the model. So we have defined the model. Next step is model.fit. Model.fit is basically a step which tell models to start training. So this step is training on data set using linear regression way. And what is the data set? This is the data set.
So
And what?
here
Yeah.
the sales and the other advertisement data will be, number of input will be same, right? In both the uh, yeah, sales and feature. Like then if you're given 10 advertisement
This
in the
is this is the input and this is the output, right? 2.1, something like this, right?
It will be always same, right? Like it,
This
like
is the this is training that is happening. So training किसका होगा? We have defined some training data set, right? X train and Y train, right? So
yeah.
training data set के अंदर whatever out of these 10 rows, whatever how many rows, 8 rows will fall under training data set. So it will train on that data set on
No,
8
that
rows.
I got it. My question is the number of input will be always equal in both the input and output.
Number of input will be same in
Let's
input.
suppose
Sorry, I didn't got your
if
question.
if we give
Hmm.
10 inputs in advertisement, then we
Okay.
have to give sales also 10
Yes,
or
yes, yes, yes. Yes, so yes. So we have seen the case, right? Sometimes the input is not there, right? We have seen when we were studying ML terminologies, right? Some of the fields were blank, right? But we are taking the dummy data set here and we are considering that we have all the output defined for all the inputs mentioned. If it is not defined, that it falls under different domain. Different domain ka matlab, then we have to do feature engineering, right? We have to fill the missing values first and then we have to go ahead, right? But here we have taken the assumption that the data we have, I mean, the output data for each of the input defined here. Okay.
okay.
So model.fit X train Y train means the training starts on the which kind of data? Training feature set. Sorry, feature training set and label training set. So X train and Y train pe I am doing the training. Now next step is to basically make prediction. Abhi, when we do prediction on test data to find out the performance of the model. So this right now, let me write this step for now, but we will not use it anywhere. We will use this step once we will finally build the ML, complete ML pipeline finally. Then we will use this step. But as this step is an important step, so I'm just, writing it as it is. And let's, so till here, our model is trained. Now model is ready, right, to do the prediction. So let's take an example of, let's take a new data set and we'll do the prediction there. Okay. So new data, let's take new data as we will directly take the data in terms of data frame. यहाँ पे advertising and let's take couple of values. Let's take 11, 12, 15, something like this. So I want to know when I'm spending $11, $12, and $15 on my advertisement, then how much sale I will get. So this will be predicted by my model, trained model. So prediction will be new prediction will be what it will be model dot predict on the new data and let's print new prediction as in the output. Okay. ठीक है. This prediction, let's see whether it works till here. And then we will form the final mathematical equation after this. Let's see if there are no syntax error, compilation error here. We could have placed some print statements also. Okay. Data. Okay. No, no, it haven't. Okay. It has ran something else. Future level selection done. What it is running? Let me check. Simple linear regress.py. Okay, dataset loaded. Okay, new prediction 15. Coefficient. No, this is something from somewhere else it is taking. 16. Simple linear regress.py should be the same file it should be running. 1 second. Loading the data set. Should be the current file. No, it's not taking from the main file. Okay, let's do one thing. Python -m. What is the name? Simple linear regress. What? Hmm. Let me close it and open it. It is picking up some other file, Python file. It is not running the current one. Let's see why it is not running. Mm. I think something is off here. Some setting is off, I believe. Okay, we'll do one thing. So I mean, it's 7:23 already. I have to drop in another 5 to 6 minutes. So let's conclude it here only. What I will pick up from next session is, so we will run this program. We will see what is the prediction coming for this new data. And then we will form the final mathematical equation. And then we will see what it basically denotes. The final mathematical equation that will be formed, how we will do the data analysis or data analytics, how we will apply the data analytics on that to study about this particular data, and how we can basically take the future decisions with respect to the advertising amount that we will spend to maximize our sale. Okay. So these things we will take, and then we will continue taking the example for multiple linear regression and so on. Cool. I think that's pretty much it then. Pretty much it then. Sorry, I have to go somewhere, so I have to drop half an hour early. And see you in next class next week. Thank you, guys.